Hi, so today I'm going to be going over Module 2 as well as my 3D diagrams of the tissues and the integumentary system. So starting with epithelial tissue, it works to protect the body in the way as the skin that covers everything, and it also is found as it lines the GI tract organs as well as all of the hollow organs. And as it's part of the epidermis, it has the ability to secrete things onto the surface with the glands that it has inside. And it is selectively permeable and has no direct blood supply to it. So my first diagram I've made is of simple ciliated columnar epithelium. So here we have the cilia, which can make things go away, like to brush away the things that we don't want to come near it. Then we have the cytoplasm. Then we have the nucleus, the many of them. We have the cell membrane to make the columns. And we have a few goblet cells. And then at the bottom we have the basement membrane that the bottom is connected to. So the simple ciliated columnar epithelium has the ability to absorb and secrete mucus and enzymes. And here are some other examples of epithelial tissue. So we have squamous cuboidal columnar, pseudostratified columnar, squamous, stratified squamous, stratified cuboidal, stratified columnar. So the simple squamous allows material to pass through by diffusion and filtration and is able to secrete lubricating substances. The simple cuboidal secretes and absorbs things. The simple columnar is what I did, and it absorbs and secretes mucus and enzymes, like I said. And the pseudostratified columnar epithelium secretes mucus, and the ciliated tissue moves mucus. The stratified squamous is able to protect against abrasions, and the stratified cuboidal is a protective tissue. And last, the stratified columnar is able to secrete and protect things. Then we go to connective tissue, which that has the ability to support, protect, and connect all other types of tissues that go throughout the body. And it always has specialized cells, and it has special fibers such as collagen, keratin, and elastic, as well as ground substance. And the special fibers and ground substance, both of those together make up what we call the matrix. And my diagram I made is adipose connective tissue. So the pink is the cytoplasm, and the green is the nucleus, and it's kind of stringy and light in some places. And adipose fat is used essentially for lipid storage, but it also can help to keep the body warm and can protect it from harm for the things that are underneath the adipose. So it's a squishy layer that protects it. Here are some examples of more connective tissue. So we have dense connective tissue, which has fibers to resist tension, which allows it to stretch and go back so it doesn't hurt itself. And the hyaline is strong and flexible. The fibrous is tough and can resist more. And the elastic cartilage is supportive and elastic. And bone is hard and gives protection to internal organs and supports the body, because bone is found the compact bone is found all over in the skeletal system to support the body in moving. And then we have fluid tissue, which is either blood or lymph, and blood is found everywhere throughout the body as it's necessary. And here we have muscular tissue, which allows for movement, for expansion and contraction for both of those. And they're excitable and usually respond to a stimulus. Some of them are voluntary, like the skeletal muscle, and some are involuntary, like the cardiac muscle that we can't control. And those we'll see on the next slide. And I made a diagram of cardiac muscular tissue. And here the long cells of the branching. We have both colors because there's a little bit difference. And there are the intercalated discs, which are how the cells are held together to each other. It's how they stay. And here is the skeletal muscle and the visceral or smooth muscle. So the skeletal muscle is responsible for movement in the body and also production of heat and to protect the organs. The visceral muscle or smooth muscle is responsible for moving food, involuntary control of respiration, moving secretions, and to regulate flow of blood in the arteries by contraction. And the last major tissue is nervous tissue, which is excitable and it is able to send and receive electrochemical signals all throughout the body to give information that it needs. And in my diagram, you can see these. The white is one of the two cell groups. These are the neurons. And then the other cell group is neurologia. And lastly, so here we have the integumentary system. And some basic facts about that is that the entire skin weighs about 9 to 11 pounds. New skin is made every 24 to 45 days. And 1 centimeter has 70 centimeters of blood vessels, 55 centimeters of nerves. It has 100 sweat glands, 15 oil glands, and 230 sensory receptors. The functions of the skin are to protect and secrete things on its surface. For body temperature regulation, it prevents water loss from the inside of the body. It's a blood reservoir. It is metabolic. It prevents UV damage. And it has cutaneous sensation, which is like itch, like if we feel an itch or pain or heat and cold. So starting in the epidermis, we have all these layers right here. So we have the stratum corneum, which is 15 to 30 layers of stratified squamous cells. This layer becomes replaced about every 4 weeks, and it's dead and dry and flakes off. And this is a protective to the layers underneath of it. The stratum lucidum is only found in thick skin, and in this one the cells are dead and flattened, and they're densely packed with eledin, which is the clear protein with lipids, and this is a barrier to water. And in thick skin, it's only for that is found on the hands, the palms of the hands, and the soles of the feet. And then we have the stratum granulosum, and that one has the name, has the word grainy in it. And that grain look is because of keratin and laminar granules, which make those little speck and dots. And this is 3 to 5 layers of flattened cells. And all of the keratinocytes in this layer start to die because they're getting farther away from the nutrients that are from the basal, where all the keratinocytes are made. Then we have the stratum spinosum, which looks spiny because of the desmosome staining. And the desmosomes are the little dots that connect each of the cells together, and the cells aren't actually touching, they're touching all of the desmosomes that connect them. This is made of 8 to 10 layers of cells, and those cells produce keratin and glycolipids. And it also includes Langerhans cells, and they are macrophages, which eat bacteria, foreign particles, and damaged cells, so all the bad things that it doesn't want. And the bottom layer of that part is the stratum basal, or the germinativum. And this is one layer of basal cells. They are cuboidal stem cells. And it makes all of the keratinocytes by mitosis. And when more cells are made, the existing cells move superficially away from the stratum basal. And this layer includes two other types of cells. It includes Merkel cells, which are another way for nerve receptors, and melanocytes, which are able to produce melanin. And this is connected to the basement membrane, and also fingerprints are able to be formed here. So the epidermis also includes the dermal papilla, which is this area right here. And then we have the hair shafts that go on the outside of the skin that we can all see. And then moving down into the dermis layer, the middle layer. So first we have the papillary region, which is able to help control the temperature of the skin. And then we have the reticular region, which in general supports the skin and all of its accessory structures. It helps hold them where they're supposed to be. And right here we have a Meissner's corpuscle, and they are for light touch receptors. And here we have a hair root bulb and a hair papilla, little hole there. And here's a subcutaneous gland, and those put subcutaneous oil all over our skin. And that is also what, when we have too much of that on certain areas like our face, that will cause acne. And then here's the follicle beneath that, all connected. And here's an erector pili muscle, and that works only when we get goosebumps. So that's the hair, or not, that is the muscle that makes the hair go erect when we get chills. And here's an eccrine sweat gland. Those are found all over the body, and they produce normal sweat, so that usually when we are too warm, too hot, those will produce their sweat onto the surface, which will then evaporate off the skin so that we can cool down. And an apocrine sweat gland, and these are only found in two main places. They're found where the hair is thicker, which is like our armpits and our groin area. And then in the hypodermis, the bottom layer, we have subcutaneous fat, or adipose, which is found all across, and that is for keeping everything safe underneath of it, for protection, and it also helps keep and trap heat in so that we don't lose too much heat. And then lastly, the Pacinian corpuscle, and similar to the Meissner's corpuscle, it does have a touch receptor, but instead of being light touch, this one is for deeper touch sensation. And that is all. Thank you.